Hello students, welcome to aimsindia online classes. This is the chemist session. Here we are discussing about the classification of elements chapter, that is about a modern periodic table. In the earlier sessions we have seen how different scientists they have tried to classify the elements and their limitations we have seen, and even we have seen through modern periodic table also, isn't it? Now we are going to see in this session some features of this modern periodic table, how it is constructed, about groups and periods. Now we are going to see. Okay, let us start this. So first let us go through the groups in the modern periodic table. The vertical columns in the modern periodic table are known as groups. There are 18 groups in the long form of periodic table. Because there are 18 columns, so they are called 18 groups. They are represented by using Roman numerals from 1 to 8 with the letters subgroups A and B. Isn't it? It is said to be the traditional notation. According to latest recommendations of the IUPAC. What is IUPAC here? IUPAC means International Union of Pure and Applied Chemistry. So according to the recommendations of IUPAC, these groups are replaced by Arabic numerals from 1 to 18 without subgroups A and B. So actually, at the earlier, the total periodic table is classified into 8 major groups. Total 18 columns are considered as 8 main groups, each group subdivided into 2 subgroups A and B. So there are totally 16 groups earlier, as per the earlier representation in the Roman numerals representation. Because in the 8th B group there are 8th, 9th, 10th columns all together considered as 8th B group. So totally 8 main groups, each group subdivided into 2 subgroups A and B. But according to the latest recommendations of UPSC, these groups are represented with Arabic numerals from 1 to 18 without any subgroup representation. Directly they are given number. Okay, suppose it is third A group, it is represented as 13th group. That's it. So we use the latest system with the traditional heading following in the parenthesis. So both are correct actually. Both are correct representations only. But nowadays what we are using the Arabic numerals. Even sometimes we use these Roman numerals along with the subgroups representation also. Okay. For example, group 2 if it is said, that means the second column in the modern periodic table. That is written as a group 2. Or it also can be represented as 2A group, second A group. If it is group 16, that means 16th column in the modern periodic table. It is represented as group 16. It also can be represented by using Roman numerals as 6A. Okay, both are correct representations only. Now, groups of elements is also called element family or chemical family. Okay, the group in the modern periodic table, the elements present in one group all together considered as element family or chemical family, and generally they are represented with the name of the first element in that group. Now let us see some groups and their representations. For example, group 1, that is the first group in the modern periodic table, first column in the modern periodic table. So these elements are having their general outer shell electronic configuration as NS1. NS1. Okay. Out of this, except hydrogen, remaining all are metals, highly reactive metals, isn't it? Lithium, sodium, potassium, rubidium, cesium, francium. These all are highly reactive metals. And these metals they form alkalis. What are alkalis here? The bases which are soluble into water are called alkalis. Now, this 1A group elements except hydrogen, they form alkalis. That is why these first A group elements are specially called as alkali metals and also called as alkali metal family. Okay, first A group elements except hydrogen. The remaining are all called alkali metal family. Why hydrogen is accepted here? Because hydrogen, even though it is present along with the remaining elements in the first group, it is a non-metal, whereas remaining elements in that group are strong metals. Observe once, lithium, sodium, potassium, rubidium, cesium, francium. These are highly reactive metals, whereas hydrogen is a non-metal. That is why first group elements or 1A group elements except hydrogen are called alkali metal family. Okay, let us see some more like this. Next, group 2, that is second column in the modern periodic table, or 2A group elements. It has elements from beryllium to radium. They are beryllium, magnesium, calcium, strontium, barium and radium. So these elements are having their in their outermost shell electron configuration as ns2. They'll be having ns2 outermost shell configuration, where n represents their outermost shell number. For example, if you see beryllium, it has atomic number 4 and its configuration will be 1s2, 2s2. So this is its outermost configuration, ns2 form. In the same way, remaining all elements also, they will be having their outermost configuration as ns2. And these elements, these second year group elements also, they form alkalis. That means the bases which are soluble into water. And one more characteristic is taken into the consideration while naming them. That is, mostly these metals are available from the earth crust. That is why these elements of second year group or group 2 elements are called alkaline earth metal family or alkaline earth metals. Okay. Next, in the similar way, 13th group or third A group elements, here these are boron, aluminium, germanium, indium and thallium. These elements are with outermost electronic configuration Ns2Np1, and these are called boron family because the starting element of this group is boron. With the name of boron, they are called as boron family. 13th column or third A group elements are called boron family. In the same way, if you see next group, that is 14th column or 14th group elements are also considered as 4th A group elements. What are those? Carbon, silicon, germanium, tin and lead, isn't it? These elements are having their outer shell configuration as Ns2 Np2, and these elements are called with the starting elements name carbon family. Okay, 13th group boron family, 14th group carbon family they are called. Next, 15th group or 5th A group elements. What are those? Nitrogen, phosphorus, arsenic, strontium and bismuth. These elements are having their outer shell electronic configuration as Ns2 Np3, and these elements are called with the starting elements name nitrogen family. And also these 5th A group elements are also called as nicogens because these elements of 5th A or 15th group can form foul smelled gases. So because of this reason, these elements are specially called as nicogens, nitrogen family or nicogens. Which elements? The 15th group or 5th A group elements are called nitrogen family or nicogens. Why they are called nicogens? Because these 5th A group elements they can form foul smelled gases. Based on this reason, they are called nicogens. Next one. Next group, that is 16th group or 6th A group. What are those elements? Here you can see oxygen, sulfur, selenium, tellurium and polonium. These elements are called 6th A group elements or 16th group elements. These elements are having their general electronic configuration as Ns2 Np4. So these elements are called oxygen family because the starting element of this group is oxygen. So they are called oxygen family. And these are also called chalcogens. Actually, the meaning or the correct meaning of this word is chalcogens, ore formers. Most of the metals in the periodic table, they are available in the earth crust in the form of either oxides or sulfides or selenites. So most of the metals are existing in the form of sulfides, oxides and selenites. In this way, most of the ores are with these 60A group elements. Based upon this reason, these 60A group elements are also called as chalcogens, which means ore formers. Okay, oxygen family is also called chalcogen family. Okay, next one. 17th group, the last but one group, that is the elements with fluorine, chlorine, bromine, iodine and astatine. These elements present in the 17th column or 17th group, which is also called 7th A group of modern periodic table. These elements are having their outer shell electron configuration as Ns2Np5, and these elements are called fluorine family because the starting element of this group is fluorine. So these elements are called fluorine family. These are also called as halogen family because these elements will responsible for the formation of salts with the many metals. So salt, the meaning of this halogen is salt former. These 7th A group elements will form most of the salts with the metals. That is why these elements are specially called as halogens or halogen family. 7th A group elements are called halogen family or fluorine family. Okay, next group, that is 18th group or 8th A group in the modern periodic table. It consists of helium, neon, argon, krypton, xenon and radon. These we know as noble gases. Their outer shell electron configuration is Ns2Np6. We know, of course, except helium. We know for the helium, the electronic configuration is just 1s2, isn't it? So it has no p subshell. Except helium, remaining all elements are having their general electron configuration as Ns2Np6. So because of this stable electronic configuration, these elements will become more stable. These are more stable elements. They won't participate in any chemical reactions. They'll be always idle. They do not react themselves also. That is why these group elements or 8A group elements are called as noble gas family. Noble gases. If we observe, all the elements in this group are gases. This is the only group which contains completely all gases. Top to bottom, all are gases only. Why so means these elements are having stable electron configuration and they do not react with any other chemicals and even themselves too. That's why always they exist in the individual atomic gaseous form. This is why reason they are also called as aerogens or ideal gases. So 18th group or 8th group elements are called noble gases or ideal gases or aerogens, and even they exist in the very small quantity in the atmosphere. That is why they are also called as rare gases. Okay, these are the different common names given for these 8th group elements. Got it? Next, now let us say about the periods in the modern periodic table. The horizontal rows in the modern periodic table are called periods. There are 7 periods in the modern periodic table. These periods are represented by Arabic numerals 1 to 7. The number of main shells present in the atom of particular element decides to which period it belongs. Yes, based upon the electron configuration of an element, we can say to which period that element belongs in the periodic table. The number of energy levels or the number of main shells present in the electron configuration of that element gives its period number. For example, if you see sodium, what is atomic number of sodium? we know it as 11. If we write its configuration, we can write it as 1s2, 2s2, 2p6, next 3s1. This is electron configuration of sodium we know. Now, if you observe the electron configuration, how many main shells or main orbits are existing in the configuration? That gives its period number. If you say first shell, second shell, and third shell, totally three shells are existing or three main shells are present in its configuration of sodium element. So, its period number is 3. In this way, the period number is given based upon the number of main shells present in the atom of that particular element. Okay. For example, one more example let us see here. Hydrogen and helium atoms contain only one main shell. Therefore, they belong to period 1. Isn't it? Hydrogen and helium both are having only one shell. Hydrogen has 1s1 and helium is having 1s2 configuration. So both are having only one shell in their configurations and hence they belong to first group. Sorry, first period. Next, the number of elements in period depends on how electrons are filled into various shells. So how many elements are there in each period? It depends upon the how electrons are being filled into various shells of the elements. We know first period contains two elements. Why it is two? That we are going to see now. Each period starts with a new main shell, S subshell, new main shell, S subshell, and ends with the main shell is filled with respect to S and P subshells. Okay, except the first period because in the first period only S subshell is being filled. In the remaining periods, a period starts with the element which is having S subshell being filled, and it will be end with the element which is being filled with the P shell of the same main shell. The first period starts with the K shell, isn't it? The first main shell, that is K shell, contains only one subshell, that is 1s. For this subshell, only two types of electronic configurations are possible. They are 1s1 and 1s2. Therefore, first period contains only two elements. See, we got the answer here. Why only two elements are there in the first period? Because the elements with only one shell are two elements only. They are hydrogen and helium. On these two, they're being filling their electrons in their 1s subshell. So 1s subshell has only one orbital, that is s orbital. It can accommodate only two electrons. So that is why only two elements are present in the first period of the modern periodic table. Now let us see in the second period. Second period starts with the second main shell, L shell. L shell has two subshells mainly. They are 2s and 2p subshells. So 2s subshell again it has only one orbital. 2s orbital will be there. We know 2p subshell contains three orbitals. 2px, 2py, 2pz. Totally how many orbitals? Four orbitals. And each orbital can accommodate two electrons. Isn't it? So totally 88 kinds of configurations can available. So 8 elements in the period for second period. Now let us see how it is. 8 types of configurations are possible in this shell, that is KL shell, from 1s1, 1s2 and 2p1 to 2p6. Totally 8 configurations. 8 types of configurations are possible in the L shell. That is why 8 elements are there in the second shell. Hence, the second period contains 8 elements. What are those 8 elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. In the order they are given. For lithium, the configuration will be outer shell configuration will be 2s1, and for beryllium it will be 2s2, and boron 2p1, and for neon it comes as 2s2, 2p6. In this way, second shell is being filled with 8 types of configurations. So there exist 8 elements in the second period of the modern periodic table. Thus, the second period consists of two S block elements and six P block elements. Say for this lithium and beryllium, last electron is present in the 2s subshell. For lithium 2s1 and for beryllium 2s2 is valence configuration, isn't it? So these two elements will come under S subshell, S block elements. And from boron, these two P subshell is being started to fill till neon. So these six elements will come under P block elements, boron to neon. Okay. Next, third period. Third period starts with the third main shell, that is M shell. This M shell has three subshells, namely 3s, 3p, and 3d subshells. But while electrons are being filled into this subshell 3d, gets electrons only after filling 4s subshell. That's why only first these two subshells are being filled with electrons. Just like the 2s and 2p, here also 8 types of configurations are possible. So 8 elements exist in the third period also. Therefore, third period contains again 8 elements, which includes 2 s block elements, sodium and magnesium, and 6 p block elements that are from aluminum to argon. Okay. Next, fourth main shell, that is N shell. This shell has four subshells, namely 4s, 4p, 4d, and 4f subshells. But while electrons are being filled into the subshells, electrons enter the atoms in the order first 4s, and then in the previous cell one it is left, that is 3d subshell. Now it is filled after 4s. So 4s, 3d, and then 4p. Now 4f is not filled. After filling of 5s and 5p, this 4f is filled. Now these three are first filled here before starting fifth shell. Now we know 4s contains one orbital, 3d contains 5 orbitals, isn't it? 4p subshell contains 3 orbitals. Totally how many orbitals? 1 plus 5 plus 3. Totally 9 orbitals. Each orbital can accommodate 2 electrons again. So this is equal to 9 into 2. How much it is? 18. So 18 types of electron configurations are possible in the fourth period. So then 18 elements are present in the fourth period. So due to this, the fourth period contains 18 elements, which includes 2 S block elements, 10 D block elements, and 6 P block elements. Okay. There are altogether 18 elements in the fourth period. How it is 14, 18, you got it? Because fourth period is the elements in the fourth period are being filling their subshells 4s, 3d, and 4p. So these subshells contain totally 9 orbitals. Each orbital can accommodate 2 electrons. Totally 18 types of electron configurations are possible, and hence 18 elements are present in the fourth period. In the same way, fifth period also contains 18 elements. They are from rubidium to xenon. There are 32 elements in the sixth period from cesium to radon, which includes 2 elements from S block and 14 elements from F block and 10 elements from D block and 6 from P block. Totally 32 elements. Sixth period contains totally 32 elements. That's why you say sixth and seventh periods are longest periods. But we know, to make it convenient in writing, these F block elements are written separately down at the bottom of the periodic table. 14 elements. So now the periodic table consists of 16 elements only in the sixth period. But actually these 14 elements which are written down in the first horizontal row, these also will come under sixth period elements only. Totally 32. 4F elements are called lanthanoids or lanthanides. Elements from cerium to lutetium possess almost the same properties as lanthanum. So the name lanthanoids is most appropriate one for these elements. So these 14 elements are written down at the bottom of the table. So these all elements are resembling the properties of lanthanum almost. That's why they are called lanthanoids. The elements after lanthanum, those 14 elements are called lanthanoids. What are those? Cerium to lutetium. Okay. Next, seventh period. Actually, it is given here incomplete. But in the latest research, scientists they have discovered those unknown elements also. Now it also contains 32 elements. Okay, 2 elements from S block, 14 elements from F block, 10 elements from D block, and 6 elements from. So some elements it is given not found yet. It is actually old book. So but here these 6 elements are also found. 6 elements from P block. Totally 32 elements in this seventh period also. So in this seventh period, the elements is the 5F elements, elements for which the last electron present in F subshell, which we are calling as F block elements. They are thorium to lawrencium. These are called actinoids because similar to lanthanoids, these elements are present after actinum and these possess similar chemical properties just like to actinum, and hence these are called actinoids or actinides. What are those? Thorium to lawrencium. These elements are in the last line, last horizontal line of the modern periodic table. Okay, the F block elements are known as lanthanoids and actinoids, are shown separately at the bottom of the periodic table to make it convenient. Right? Now let us see one more. Metals and non-metals in the periodic table. All the elements in S block are metals except hydrogen, whereas P block, in the P block there are metals, non-metals, and even metalloids also. If we say this is a periodic table, S block contains almost all the metals except hydrogen. But P block contains, if you see P block, these are metals, these are non-metals, and these are metalloids. D block and F block also contains mostly metals. Different kinds of elements are present in mostly in the P block, that is metals, non-metals, and metalloids. In the periodic table, you will notice a staircase like demarcation, isn't it? See this staircase like representation. The elements to the left of this demarcation are metals. These all are metals, and right to this right side elements are non-metals, and the elements represented in this staircase, those are boron, silicon, germanium, arsenic, strontium, tellurium, and astatine. These elements are called metalloids because these elements exhibit the properties of both metals and non-metals. That is why these are specially called as metalloids. Okay, the elements which possess the properties of both metals and non-metals are called metalloids. Okay, this is about the some features of modern periodic table. Thank you for watching our video. Please subscribe our YouTube channel, and that is Aims Today for latest updates and recorded videos.